Hi everyone. In today's class, we are going to discuss about the solution of PDE is in the form f of p comma q equal to 0. Keep it in mind, the partial differential equation is in the form f of p comma q equal to 0. That is, the PDE is purely in terms of p and q. P plus q equal to 1, whether p plus q equal to 1 or pq equal to 4 or p square plus q square is equal to 5, such that purely in terms of PQ, purely in terms of P and Q. Now we are going to discuss the solution, how to find the solution for this particular PDE. Let us start the solution. Once again, I check the equation. The given equation purely in terms of PQ. This is the procedure. Let us given the given equation is in the form f of p comma q equal to 0. Consider the given equation as equation 1 p plus q equal to pq. Let us consider it is in 1. Then we are going to find the three types of integral. One is complete integral, another one is singular integral, third one is general integral. Let us do one by one to find the complete integral. How can you find the complete integral? For this type, particularly for this type, the trial solution is taken as, for this kind of PDE, the trial solution is taken as, the trial solution is z equal to ax plus by plus c. This is our trial solution for this particular kind of PDE. So memorize this equation, z equal to ax plus by plus c. This is our trial solution. Mark this equation as 2. Mark this equation as 2. Given equation is considered as first equation and the trial solution is considered as second equation. Now, how can you find the complete integral? Partially differentiate 2 with respect to x and y. Partially differentiate equation 2 with respect to x and y. With respect to x and y. What can we get? Dou z divided by dou x equal to. This can be taken as P. P equal to partial differentiation with respect to x is considered as P. P equal to, if we are differentiating with respect to x means we can straightly get A. We can straightly get A. So partially differentiate with respect to A. P is equal to A here. Now differentiate with respect to y. Dou z by dou y equal to, this can be taken as Q. Q equal to B. Q equal to B. That is P equal to A, Q equal to B. This equation is considered as equation number 3. Equation number 3. Now consider this equation as 3. Let us proceed. So first we have to find the complete integral. For that complete integral, start with the trial solution. The trial solution is taken by z equal to ax plus by plus c, and then partially differentiate with respect to x and y. We will get the p and q value. Now substitute this value in equation number given 1, that is given equation. Sub p comma q value in given equation, that is in equation 1. This is our given equation. In equation 1, what can we get? Instead of P, we are having A plus B equal to AB. A plus B equal to AB. From this equation, try to find the value for B. AB minus B. That is, if we take B as a common, A minus 1, we need B value. So B equal to A divided by A minus 1. We need B value only. B equal to A divided by A minus 1. Now, sub the value for B. Sub the value for B in the trial equation. Trial equation is considered as now equation number 2. Sub the value for B in trial equation. Then what can we get? Sub B value. Sub B value in 2. Sub B value into 2. That is Z equal to, what is our 2 here? What is equation number 2 here? Equation 2 is AX plus BY. AX plus BY plus C. So Z equal to AX. Z equal to AX. AX, instead of B we have A by A minus 1 into Y plus C. Now let us write clearly Z equal to AX plus A divided by A minus 1 into Y plus This is our required complete integral. This is our required complete integral. Now, this equation is marked as 4. This equation is marked as equation number 4. Equation number 4. This equation is marked as equation number 4. Now, our complete integral over. How can we find the complete integral? From the let us consider the trial solution as z equal to ax plus by plus c. Then partially differentiate with respect to x and y, we can get the value for p and q. Now, try to find the value for b from the given equation. Then substitute the value for b in trial solution. That is called complete integral over. Then move on to singular integral to find singular integral. Particularly, there is no singular integral for this type, so you can directly write there is no singular integral for f of p comma q equal to 0. For f of p comma q equal to 0, there is no particular singular integral for the particular PDE f of p comma q equal to 0. Simply we can write there is no singular integral for this type. Then what about the remaining one? We need to find the general integral. We need to find the general integral. Let us try the general integral. Try to find the general integral for this PDE to find general integral. So, to find general integral, how can we find general integral? Let us substitute. Let c equal to f of a in equation number 4 in complete integral. C equal to f of a in equation number 4. Then what can we get? Z equal to ax plus a divided by a minus 1 into y plus f of a. Now partially differentiate with respect to a. Partially differentiate with respect to a. We can get dou is and equating to 0. And equating to 0. Dou is set by partial differentiation. After that equating 0, we can get differentiation. Partial differentiation with respect to a means a differentiation 1. The remaining is x. Then here there are two terms in numerator and denominator. What we are very well know about the formula d of u by v equal to v u dash minus u v dash divided by v square. This is our differentiation formula. Now apply this formula. X divided by a minus 1 the whole square, a minus 1 into 1 minus a into denominator differentiation 1, a into denominator differentiation 1. This is the formula we are applying in this step. This is the formula we are applying in this step, u by v formula. Now we are numerator is considered as u and denominator is taken as v. After differentiating the third term, we can get f of a differentiation f dash of a. We are equating this term equal to 0, so put equal to 0. Simplifying this one, furthermore simplification, x plus this a minus 1 and minus a divided by a minus 1 whole square plus f dash of a equal to 0. Now, this a get cancelled with minus a. So, the answer is minus into minus will be plus x plus into y. X plus into y. So, x plus 1 by a minus 1 whole square into y plus f dash of a equal to 0. Once again we can write clearly x plus 1 divided by a minus 1 whole square into y plus f dash of a equal to 0. F dash of a equal to 0. Now, this equation is taken as equation number, already we are named the equation up to number 4. So, this equation is taken as equation number 4, equation number 5. Equation number 5. Now, eliminating this constant a from these two equations, we can get the general integral. Eliminate a between these two equations. What are they? Eliminate a between these two equations. First equation is c equal to f of a. Putting c is equal to f of a, this equation, suppose we are named it as, for our convenient, this equation is named as For our convenient, this equation is named as equation number 4. Equation number 4. Already we are named up to equation number 4, so I named it as 5. And last equation is named it as 6. Last equation is named it as 6. F dash of A equal to 0. We named it as 6. Eliminating A from 5 and 6. Eliminate A from 5 and 6. We can get the general integral. We can get the general integral. So no need to eliminate the constant A, just you write it as eliminate A from 5 and 6, we can get the general integral. This is the solution for the particular PDE is in the form f of p comma q equal to 0. F of p comma q equal to 0. This is the solution procedure. Once again I explain the procedure in consolidated. Let us start from the first step. What is our first step here? Okay. So listen carefully. The particular PDE is in the form Fp plus Q equal to Pq, that means f of p comma q equal to 0. So I mark it as equation number 1. Then this equation has 3 types of integral. First one, complete integral, singular integral, and then general integral. Let us try to find the complete integral first. Let us try to find the complete integral first. How can we find the complete integral? By taking the trial solution z equal to ax plus by plus c. Z equal to ax plus by plus c. This is our trial solution. Now, the trial solution is partially differentiated with respect to x and y. We can get p equal to e and q equal to b. Then substitute the p and q value in the trial solution, the given equation. That is, given equation is p plus q. Given equation is p plus q equal to pq. In place of p we have a value, and place of q we have b value. So just to substitute a and b value, b equal to a by a minus 1. Now, in trial solution, substitute the value for b. What is our trial solution here? Is that equal to a plus ax plus by plus c. So ax is as it is ax. Instead of b, we are having a by a minus 1 into y plus c. Now, this particular type of PDE have no singular solution. So you just leave it. There is no singular solution for this particular type. Then move on to the last integral, that is general integral. How can we find the general integral? At last, we are getting the equation number 4. In equation number 4, put c is equal to f of a. Therefore, put c is equal to f of a here. This equation is considered as equation number 5. Then, differentiate partially with respect to a. Differentiate partially with respect to a. This fifth equation is differentiate partially with respect to a. So, differentiation, it will be and equating to 0. So, after differentiating with respect to a, we can get x. Here, we have to apply u by v formula. Then f differentiation f dash of a. So eliminate a between these two 5 and 6 equation. Eliminate a between these two equation. We can get the general integral. This is the solution procedure. Thank you. We will see in next class.